Yes, can you see the screen, guys?
Yes, sir.
Okay, okay. So F block elements, right? We are done with D block elements, and we have to learn about the F block elements. Okay, F block elements. Fine. So first is, what is the F block elements, right? What are the F block elements? So generally speaking, the elements in which the last electrons enters F subshell are called F block elements. Okay, are called F block element. Now these are also known as, okay, where is the F block situated in the periodic table? The F block is situated or rather I should say placed, is placed. The F block is placed below the main table, right? Below the main table, main periodic table, I would say, main periodic table. Okay, and this is the reason they are also known as inner transition elements. They are also known as inner transition elements or inner transition metals. Fine. Now, next is the F block elements. Okay. So these F block element, they consist of two series. One is named as lanthanides. They are also known as lanthanides. Okay, whatever you call them. And secondly, we have actinides or actinides. Okay, so general introduction about the F block elements. Please write it down. Let me know if you're done. Okay, one more thing you can write is there are 14 elements, right? 14 elements. 14 nahi hoga, 14 plus 14, there will be 28 elements. Here we have 14 elements. And in this series, we have 14 elements. According to this year's syllabus, we have to just learn about the lanthanides, okay? Please let me know if you're done writing. Okay, Amalya is done. Okay, all of you are done. So the first of them is lanthanoids or lanthanides. क्या वो अबीर ज्वाइन नहीं किए हैं अभी तक? ओके so this is a series है ना, this is a series of elements starting from series. Okay, series of elements following, that means after lanthanum, that is 57, atomic number is 57. Okay, so after lanthanum, whatever is present, we call them lanthanides. Series of elements following lanthanum are called lanthanoids. Okay, and in lanthanoids, the 4f orbital, 4f subshell is consecutively filled. How many elements will be there? So in 4f subshell, there can be 14 electrons. Hence, we can add 14 electrons, right? So if we are adding 14 electrons, that means we are adding 14 protons also consequently. And after each addition, we are getting a new new element. That is why we have 14 elements here. 14 elements. There are 14 elements in the lanthanide. There are 14 elements in lanthanide. अबीर आप यहां से कीजिए अभी, है ना, एंड में हम दिखा देंगे आपको. ओके अबीर, जस्ट लीव अ हाफ पेज स्पेस. ओके,
Yes, sir.
okay, है ना, 14 elements. There are 14 elements. Now, what are the most important properties? Now, talking about properties.
Sir,
Yes, Faisal.
sir, the first point, series of element following lanthanum 57. So lanthanum is also included or it is excluded?
Lanthanum should not be included. Okay, lanthanum should not be included after lanthanum.
So from 58 to start.
Yeah, but generally, if you see the D block elements that they show, they start with lanthanum only. Some people, they don't. In some of the books, they will not. But if you look at the table, so you have to start from cerium and end with I think that will be 71. Don't know what the atomic something. I think glutanium or some element will be there. So you start with 58. Okay, then you will see that there are 14 elements from 58 to 71. Okay, not 57.
Yes, sir.
Right? Okay. Following lanthanum. So when you have when the question comes na, you try to keep this point, because जैसा आपको है ना वैसे ही, now this is a point in which there is a point of difference whether to include lanthanum in the D block or in the F block elements. So what you should do is you should keep the definition like this, है ना? Series of element following lanthanum are called lanthanoids. Okay, so आपके टीचर का जो भी perspective होगा, he will give you marks in this. Okay, so write this. What are lanthanides? Write the same statement. Okay, write the same statement. Next is properties. Now, in the most important property of lanthanides is that they are used in preparation of alloys. They are used in preparation of alloys. Next is they are soft, malleable, and ductile. but with low tensile strength. Okay, now this is the general property. Now we'll look at the chemical properties. Okay, chemical properties means that oxidation state. What is the oxidation state? What is the color? What are the magnetic properties? And how do they react and all these things? So in chemical properties, I will start with the most important thing, that is oxidation state. Okay, that is the oxidation state. So the most stable oxidation state +3. Most stable is +3, but also, and they also exhibit and they also show +3 and +4. Okay, now these are observation. Now why they show +2 and +4? Why do they show +3 only, right? Why is it is most stable oxidation state, or I can say that most common, I will say most common, not stable. Most common oxidation state is +3. Now why it is +3? It is still not discovered exact reason why it is +3, and how can they show +2 and +4 also. Now some people, they relate it to the s electrons, those are which are present in the latter orbitals, right? The latter orbitals, as we saw in the d block elements also. Now in oxidation state, +2 and +4 is most stable. Next is the color. Okay, color. Some of the elements, some of the lanthanides in their +3 oxidation state show color due to, what is the reason for color in d block elements? TD transition. What is the reason for color in F block elements? FF transition, due to FF transitions. There will be electron in F subshell. Light will come, it will hit the electron will rise up, will absorb energy. Some of the light's energy will be absorbed, and some of them it will be reflected back. Okay, they will be reflected back. Now next is magnetic property. Next is magnetic property. Now I hope you guys remember, if we have unpaired electron, then only we will be having some magnetic property. Okay, so there are only few lanthanides which don't have magnetic property. Otherwise all of them will have some magnetic property. Okay, so La3 plus, okay, La3 plus and Lu3 plus have 4f0 and 4f14 electronic configuration. Okay, and that is why, hence, they don't have magnetic moment. Okay. Now, other than that, all the trivalent lanthanide ions, they are paramagnetic. Other trivalent Lanthanides are paramagnetic. Due to presence of unpaired electron. Due to the presence of unpaired electron. Okay. Now, you write this much, then we will talk about a important point from where the questions come. That is lanthanide contraction. इसको लिखिए आप लोग पहले. Okay, Abir is done. Just waiting for Faisal. Okay, everyone is done. Now, please listen very carefully. Don't write anything, okay? Don't write anything. Lanthanide contraction. Lanthanide contraction. Now, what is meant by lanthanide contraction? We have, wait a second, let me get a photo of F block that will be helpful for me. Okay, so when you start from here, okay, 57, 58, 59, what are we doing? We are adding one electron and one proton as we move rightward. Yes or no, guys? Correct? As we move this way, what is happening?
Yes, sir.
The proton number is increasing. The proton number is increasing. And where is the electron going? Electron enters the F subshell. Right? Yes or no? As we go
Yes, sir.
left to right, in a series. Now, the electron is going to F subshell. General electronic configuration, the general electronic configuration of lanthanide, those will be what? It will be Xe, because xenon will be the element, that is the xenon will be the noble gas, and after that we will have 6s2, 4f, n. So n will be 0, then 1, 2, 3, and so on. It will go on increasing. Okay, it will go on increasing. So the electronic configuration is like this. Now you can see that the electron is entering in the F subshell, but the outermost electron is the sixth shell, right? So you have this proton here, 1, 2, 3, 4, 5, and then I will mark 6 like this. And let me also give some kind of respect to the fourth one, because here is also some value present. Okay. The electrons are entering here, right? And we have, but as the electron enters, the proton number will also increase, right? Proton number will also increase. But we have here 2 electrons, which determines the atomic radius, right? The sixth shell here, it will determine the atomic radius, right? Not the 4f, because 4f is inside. 6s is the outermost shell. 6 is the outermost shell. That is why sixth shell, it will be determining the atomic radii, not the fourth shell. Now, when we increase the number of electrons in F subshell and we increase the number of proton here. So when we increase the number of proton, what happens? These protons, they can attract the outermost electron more effectively. Why? Because this 4f subshell, it is very diffused and it has a very low screening effect. Even though if we are adding the electrons, those electrons which are added, they will not play a major role. Rather, the protons which are added, they will be used to attract the outermost shell. And as a consequence, if the attraction between the outermost electron, please listen very carefully. If the attraction between the outermost electron and the nucleus increases, the size will increase or decrease. Tell me, if the attraction increases, what will happen to the size?
Size will decrease.
Size will decrease. Okay, very good. Size will decrease. Now, this is what happens. That is why it is known as Lanthanide contraction. Okay, this is known as Lanthanide contraction. Now, what happens here then? What happens here? We'll write like this: with increase in atomic number, the atomic and ionic radii decreases from one element to another. Why is this happening? Due to increase in protons and low screening effect of F block elements. Sorry, of F subshell. Of the F subshell, okay? Of the F subshells. This is known as the Lanthanide contraction. So when they will ask what is Lanthanide contraction, you will first of all write with increase in atomic number, the atomic radius and the ionic radii decreases from one element to another, and then you will give the reason due to increase in the protons and low screening effect of F subshell. Okay, now write this much. Let me just the electrons enter the F subshell. We have to write from here, right?
So this table we have to draw.
नहीं table नहीं draw करना, वो तो बस ऐसे ही रखा था.
Okay, sir. So what is GEC?
General electronic configuration. Then guys, yes or no?
Yes, sir.
What about others? Faisal?
Yes, sir.
Done. Okay. No. Okay, Nazar is done. Amalia, you are not done. Done. Okay, okay. Now let us look at the periodic table, and from here you will understand what is the consequence of this lanthanide contraction. Okay, what is the consequence here? Okay. So I need to get a wait a second, a good better one. Yeah, right. This is good. You can see the atomic numbers now. That's what I want. You can see the atomic numbers. Okay. So as you can see, here should be lanthanum, right? Here should be lanthanum. Here should be actinium, lanthanum and actinium. Okay, so we'll not worry about actinium. We'll worry only about the lanthanum here. So after we go from xenon, we go cesium, barium, and then we go lanthanum, which is 57. And after that, lanthanum is 57. Then we directly go to hafnium, which is 72, right? Why? Because 57 to 71, we have the F block elements which come in between the S block and the D block elements. Can you see that? Yes or no? Tell me. Can you see that, guys? That after lanthanum, we are directly going to 72. Yes or no?
Yes,
Yes,
sir.
sir.
Right? You're directly going to 72 atomic number. Now, then another thing is that as we go from 57 till 71, the size decreased. Right? Yes or
Yes.
no?
Yes, sir.
The size decreased. Now, and further, if I go from 71 to 72, 73, 74, size will further go on decreasing. The size will further go on decreasing. Okay, so one phenomena that you should consider is size is decreasing. Okay, as we go here, the size is going to decrease. From xenon to cesium, barium, the size is fine. Then lanthanum, after lanthanum, the size starts to decrease. The size starts to decrease, and it drastically decreases due to the lanthanide contraction because the electron enters the F subshell. The F subshell cannot screen. That is why the valence electrons are they are attracted towards the nucleus most effectively. So the consequence is that this is our first transition series, right? Scandium, titanium, then second transition series, and this is our third transition series starting from lanthanum till mercury. So if I go from second to third transition series, we are going below, and when we go below, the size should increase, right? What is the expected order here? If I go from the third shell to the from the second series to the third series, the size should increase. But what happens? The size is almost constant. It does not increase very much if I go from the second transition series to the third transition series. Okay. So what I'm writing here is the effect of lanthanide contraction. Okay, effect of lanthanide contraction. What is the effect of lanthanide contraction? The effect is the size of first, second, third transition series. Third transition series is not as expected. They have similar size as that of second transition series. Okay, as that of second transition series. Okay, so this is the only point, that is the effect of the lanthanide contraction. Okay, So please write this down. Abir is done. Okay. Waiting for Fatima. Fatima is also done. Okay. Now, this is the effect of lanthanide contraction on other elements. You can have a direct question like this. What is the effect of lanthanide contraction on other elements? So here, which element is affected? The third transition series elements, these are affected. Okay. Now, in terms of what is the consequence or what is the effect of lanthanide contraction on the molecules or the elements of lanthanides? So the first is the basic character. Okay. Basic character. Basic character of hydroxides. Okay, basic character of hydroxide. Now, when we go from lanthanum to lutetium, from La to Lu, what happens? The basic character increases. Basic character increases. From LaOH whole thrice. Oh, wait a second, sorry. Should have written decreases. Decreases from LaOH was lanthanum to lutetium, it decreases. Okay. Now, why does it decrease? Can anyone comment? What it has to do with science? Okay. See here. When I go from lanthanum to lutetium, so La3 plus to Lu3 plus, what happens? Size decreases, right? And size of what decreases? The size of cation. Na? This is lanthanum, this is lutetium. Cation decreases. So what does, if size of, this is size of cation decreases. Size of cation decreases. Now, when the size of cation is decreasing, what is happening? This positive charge, small positive charge, and if we have a huge negative charge here, what will happen? This positive charge will attract the electrons like this, and it will distort it, right? It will distort it, and the electrons will be, the anion will have this type of shape. Here is the nucleus, and here we have the other nucleus, and there are electrons in between the nucleus. So what happens when the size of cation decreases? Covalent character increases, because what is a covalent bond? When there are electrons between two nuclei, those are covalent bond. Now, if I have two ions in which the positive charge is very small, it will distort the negative charged anion and it will keep some electrons between those two nucleus, and it is moving towards a covalent bond because these are somewhat sharing the electrons, right? So when the size of cation decreases, covalent character increases. And if the covalent character increases, what happens then? Then the possibility of ionization and ionic character decreases. And if ionic character decreases, they will not get dissociated. Okay, since increase in covalent character, covalent nature leads to less dissociation of ions. Hence, the basic character decreases with decrease in size of cation. Okay, so please write this down. When the cation size decreases, covalent character increases, ionic character decreases, rate of dissociation also. Dissociation will also decrease, and that's why the basic character will decrease. Okay, write this down. Last point that you can write is about the separations. Okay, due to decrease in size, or rather I should say due to lanthanide contraction, lanthanides are difficult to separate. Okay, lanthanides are difficult to separate. Write this last point, then you're done. Other points you can also write about the electronegativity, because size is also dependent on electronegativity, but these are metals, so I would not write. अगर last में कुछ point याद नहीं रहा आपको, then you can write this in the examination. The electronegativity increases from lanthanum to lutetium. Okay, so done. Nazira is
Yes,
done,
sir.
Amalya is done. Okay.
Yes, sir.
Now you guys have a homework. Okay, you guys will send me homework. आपका homework रहेगा. write the electronic configuration. Write the electronic configuration from lanthanum, which will be how much? 57, na? 57 to lutetium. What will be the atomic number for lutetium? Lutetium is 71, I guess. Okay, and also mark the exceptions. Also mark the exceptions. जो भी आपको लगे ना, this is okay. Obviously, you will copy these electronic configuration. आपको ऐसे लिख के नहीं लाना, ठीक है? Copy this because in the F block element there are total of 10 exceptions. Okay, in the F block element itself, including the lanthanides and lanthanides. So what you will do, you will go to NCERT. वहाँ पे होगा. There you will write the electronic configuration and then mark up what are those exceptions. Okay, and then we can discuss those exceptions in the next class. Okay, guys. So the F block is also complete. In the F block elements, most important part is the electronic configuration. वो आपको element दे देंगे, इसका electronic configuration लिखो. तो उसके लिए कुछ नहीं, अगर exception से दे दिया तो याद करके ही जाना पड़ेगा, है ना? There is no logic to that. You just have to remember it. Okay, and then you can also blame the teacher कि कैसे बेवकूफ आदमी है उसने, मतलब like they should give logical questions rather factual questions. Okay, so can you show the first notes? Yeah, I will show you the first notes. Yes, here, Abir. Okay, main important points here is the oxidation state. Please remember 2, 3, 4. है ना? 2, 3, 4. These are the oxidation state of lanthanides. 3 is the most common one. 3 is the most common one. Then the lanthanide contraction. And in lanthanide contraction, there are 3 things. What is lanthanide contraction? That is the decrease in size from lanthanum to lutetium. Why it happens? Due to the addition of electrons in the F block, which is not very effective in screening those outermost electron of 6s. Now, what then the next thing is, what is the effect of lanthanide contraction on other elements and the compounds, or on lanthanides only, or on lanthanides only? Okay, so there are 3 things: what it is, why it is, and what is the effect of that lanthanide contraction. Okay, so mainly 3 points: electronic configuration, oxidation state, and the lanthanide contraction and its effect. Okay, guys. Chalo. Thank you very much. Thank you for cooperating with the time change. है ना? Actually, there was a funeral and I just wanted to attend that because वो मेरे एकदम like घर के सामने ही था. Like he was my neighbor. Okay.
It's okay.
That is all done. Okay, fine. So thank you, guys. We will meet on Saturday then. Okay.
Yes, sir.
Okay, sir.
Okay.
Thank you, sir.
Allah Hafiz.
Thank you. Allah Hafiz. Assalamu alaikum.
Thank you, sir. Walaikum assalam.
Thank you.